Okay, in this video I'm going to show you how I process the source lists, kind of clean up the data here and get ready for plotting graphs. So what I've loaded in here already is the CSV file that I created with Aperture Photometry tool. And this is all of the data for the 10-second series. So there are stacked images of I believe 20 seconds, 40 seconds, 60 seconds, all the way up to a stack of 300 seconds. And all the star data is in here. And fortunately, let's see, the first thing I like to do is kind of get the columns distributed evenly so it's easier to read. And fortunately, we're only interested in about 3 columns in here. The source intensity, source uncertainty, and the magnitude. Now, first thing we want to do is create a column for the signal to noise ratio. So I'm just going to highlight this column, right click and insert. I'm going to call it SNR, and this is going to be equal to source intensity divided by the source uncertainty. And in Excel, you can come here to the corner where you've got the little solid cross and drag all the way down here, and you will fill in all of these rows with the corresponding formula. However, also in Excel, a perhaps easier way is to come to this first one and just double click on the corner where you've got the solid cross. Perhaps an easier way is to come to this first one and double click on the corner with a solid cross, and that will fill them all the way down to the bottom. So here we've got our column of signal to noise ratios. Now over here, the magnitudes in this case have already been converted to standard magnitude by adding the magnitude 0 point in Aperture Photometry tool when we took the measurements, when we did the measurements. However, if you didn't, if these are instrumental magnitudes, then these are going to be numbers like -10, -4, -6, etc. If that's the case, then you need to create a column here and call this, standard mag. And this is going to be equal to the instrumental magnitude plus your magnitude 0. In the case of this series, it was 26.66. And then you would carry this column on down. Okay, but since we don't need to do that, I'm going to delete this column. So we have our signal to noise ratio and our standard magnitudes. And those are really the 2 columns we want. So the next thing I like to do before getting into processing or creating graphs is to create a filter. I come up here to the first one and create a filter. Then I'm going to redistribute the columns so it looks pretty. And at this point you can start hiding some of these if you want. We're not interested in anything here. These are not going to be of any use to us for now, so we can hide that. Don't need this data units column, so we can hide that. Don't really need the magnitude uncertainty, but I'll leave it there. And don't need any of these other ones here except I'll leave the radial profile one in there because I want to talk about that later. So hide all these. Now we really have narrowed that table down to signal to noise ratio, magnitude, magnitude uncertainty, radial profile, and then the file name. So this table is now pretty much ready to process and start creating graphs and calculating trend lines and formulas. So what I like to do now is File, Save As. I don't want to save it as a CSV file anymore. Save it as an XLS file. And of course, if you're using LibreOffice, the extension here is going to be different, some different extension. But you want to make sure you save it in the default format for the spreadsheet program. And we'll just call it summary 10-second test. Okay, so here is all of the star data. Here's the first image, second image, third, fourth, fifth, sixth, all the way down to the bottom one. And what we're going to do next is to filter these by a couple of things. So I think that's it for this video. Thank you very much for watching.